Hi there, welcome to JEE Advanced 2020 Solutions by Genesis. We will now discuss Paper 1, Section 1, Question number 4. Now this is the question, and if you haven't seen the paper, I suggest you pause the video and read the question. In this question, we have a coil which is submerged in an external magnetic field, and the coil in turn is connected to a capacitor which is fully charged. When the switch is closed, the capacitor discharges. They have mentioned in the question that the discharge time is very short, and in this time they have asked us to consider that the coil is hardly rotated. They have given 4 options: that when the capacitor has discharged completely, what is the angular momentum of the coil? As the capacitor discharges through the coil, a short burst of current flows through it, and in that duration the coil experiences a torque due to the magnetic field. This torque is impulsive in nature as the current lasts for a very short time, and it is the angular impulse of this torque that imparts the angular momentum to the coil. The magnetic moment of the coil has a magnitude P is equal to N into pi r square into the current I. The magnetic moment vector P vector is normal to the area and therefore also to the magnetic field. Therefore P vector is perpendicular to B vector, which gives the magnitude of the torque, which is the cross product of P vector and B vector, simply as Ni pi r square B. Now if we apply angular impulse momentum theorem during the discharge time of the capacitor, delta L is equal to integral tau dt basically gives us L minus 0 is the initial angular momentum, L minus 0 is equal to integral of the torque is Ni pi r square B dt. Now everything, if you see on the right hand side, comes out of the integral, and we are left with only integral I dt. But integral I dt is nothing but the total charge that flows through the circuit, which is essentially the initial charge of the capacitor, and this gives us the angular momentum as pi n cube b r square, and therefore B is the correct option. This is again a very straightforward question for magnetism, and as long as you've read magnetism, this should be a doable question.